So let's start with the concept of subsets. In my opinion, probably at this level, this would be the most important concept or technique that you will deal with. And most of the problems would involve having subsets that you're going to come across. So let A be a set. So let B be a set. B is called a subset of A if every element of B is an element of A. So essentially it has some or all elements of set A, and the limitation is it can only have some or all elements from set A. It cannot have other elements which are different or which are not contained in the set A. The notation for a subset is this, where we denote with this particular notation that B is a subset of A. Now, here are some additional statements that we can derive just from this definition of a subset. So let's take a step back and realize what a subset actually is. The conditions are that for a set to be a subset of A, first of all, it can have only elements or all the elements of that particular set A. It cannot have any other elements which are not contained in that particular set A. So the first statement that we can derive from the definition is the set A is itself a subset of A. Another definition that we can derive from this particular definition of subset is the concept of proper subset. Any subset B of set A which is not equal to set A is called a proper subset. To denote what a proper subset is, we usually use this notation. So in this case, this is pretty much equivalent to saying that the particular set B is a proper subset of A and B is not equal to A and B is a subset of A. These two concepts together implies the concept of the proper subset. Now there is a third statement that we can derive from the definition of subset, that if A is a subset of B and B is a subset of A, then A is equal to the set B. Let's break this particular statement down. Now, there are two parts to this particular statement. The first part is that A is a subset of B, which means every element of A is an element of B. Now the next part, B is a subset of A. So here every element of B is an element of A. Now obviously both the sets A and B cannot have any other elements which are not present in the set which it is a subset of. So if every element of A can be found in B and every element of B can be found in A, then A and B both has the exact same number of elements. Hence, we say that both these sets A and B are equal. Now we are going to introduce another symbol. It is extremely important whenever we deal with higher math or whenever we start writing or start formalizing math from plain English. This particular symbol is known as implies that or implication signed. So let's take the example of a subset and see how this symbol helps us. Once again, the definition of a subset is every element of set B has to be an element of set A, or in other words, the subset B will have zero, some or all elements of set A, and it won't have any other elements which are not contained in set A. So we can say if X is an element of B, we have already learned the notation of what is an element of or does belongs to in our last lecture. So if X is an element of B, then we imply that X is also an element of A. And this is exactly what the definition of a subset is, formalized in math notation. The English statement for the above statement is X belongs to B implies that X belongs to A, which is just another way of stating every element of B is an element of A. Now I'm going to introduce another notation, which is the double implication sign, which can be read as implies and is implied by. So essentially, let's take this particular example. If A is a subset of B, we can reformulate this statement in math notation as X belongs to A implies X belongs to B, and the second part we can formulate this particular statement as X belongs to B implies X belongs to A, and we can combine these two statements together to form a double implication, which means not only X belongs to A, it implies X belongs to B as well. Let's rephrase it. X belongs to A implies and is implied by X belongs to B, and hence A is equal to B. Now, if you remember in our previous lecture, we have had this particular phrase, if and only if. The double implication sign can also be read as if and only if. But for now, we will be sticking to implies and is implied by at this particular stage. The preliminary concept of what subsets are is over. We will be taking a look into some set operations, such as the intersection of sets, the union of sets, and some operation involving the intersection and the union of sets later. We will also look into the difference of a set, the symmetrical difference of a set. So there are a lot of things to cover before we can say we are pretty much proficient in what a set is and we can start solving problems, interesting problems with sets.
Thank you so much for tuning in, folks. If you enjoyed today's video, make sure you hit the like button. It really helps the channel out. Don't forget to subscribe and ring that notification bell so you never miss out on our upcoming content. Have a question or want to discuss further? Drop a comment below. I'm always eager to delve into these problems with you. As always, thank you for your support, and we will catch you in the next video. Stay awesome.